This note is a low E, but if I pluck this string, I get the note D, which is higher, 10 semitones higher, in fact. Yeah, music. But if I fret this note on the first string and pluck it, I also get the same D note as before, though it might not be in tune. Today, we're going to fix that. Hello and welcome to Underdog Physics. First things first, when we pluck a guitar string, we're actually hearing a combination of lots of standing waves that fit on that string simultaneously. The main one that we hear is the fundamental frequency. That's the lowest frequency, or the longest wavelength, that'll fit on that string. Yes. Anyway, fretting a note on a guitar means pressing down the string so that the length of string that can actually vibrate is between the bridge and the fret wire here. By shortening the length of string that can vibrate freely, we're limiting the largest wavelength that can fit on that string. So the fundamental frequency of, say, this section of string is higher than the fundamental frequency of this section of string. We can see this from the equation in my other video. When tension and mass per unit length is fixed, the fundamental frequency is inversely proportional to the length of the string. Longer string, lower frequency. Shorter string, higher frequency. However, this is assuming that tension and mu are constant. They might not be. Well, guitar strings are made very well nowadays, so they're effectively uniform. So we can assume that the mass per unit length along the string is unchanged. However, when we fret a note, we'll be increasing the tension ever so slightly because the act of pressing down the string is stretching it slightly. Take a look at this exaggerated cartoon. This length of string would give an E note. If we somehow forced only half the string to vibrate at its fundamental frequency, the wavelength would be half the length of before. So the frequency is twice as much as before. Let's fret the E note, which is an octave higher, by pressing it down against this 12th fret. The section of our string that we want to vibrate is now actually the hypotenuse of a right-angled triangle. Notice how it's a little bit longer than it used to be? Well, this act of stretching the string has increased the tension on it. Whoops! What a mess! Good news! We can compensate for this by adjusting the intonation of our guitar. Adjusting the intonation basically means ensuring the length of the fretted string is what it needs to be to give the right note, now that the tension has changed because we've pressed the string down. To adjust intonation, first tune up your guitar, preferably using a precise tuner, and make sure that your tuning is as accurate as possible. Then fret the 12th fret of a string of your choice and play it to see if it's in tune. If it is in tune, you don't have to do anything. Hooray! If it's sharp, too high, we compensate by moving the bridge saddle backwards. Retune the guitar, then check again. If it's too flat, so too low, move the saddle forward, retune the guitar, then, you guessed it, check again. A correctly intonated guitar will have bridge saddles that are staggered a little bit like this, rather than all the saddles being in a straight line. The precise position of the saddles on your guitar depends on a couple of things, so it might be a little bit different. It depends on the kind of strings you have, the action, which is the height of the strings away from the guitar body, and what tuning you set your guitar to. Your best bet is to adjust the intonation little by little until it's just right. Thank you so much for watching. I hope you found this useful, and feel free to like, share, subscribe, and if there's any videos you'd like to see in upcoming videos, stick them in the comments below.